And tonight it's my privilege to host this third of our Tuesday night education series. My privilege to host uh, Bruce Edgerly, Edge from BCA, co-founder and brand ambassador. And he's got some compelling slides for us on recognizing and mitigating electromagnetic interference. Uh, I've I got the privilege of previewing some of his slides with him, and it's going to be a really exciting evening. Just in terms of run of show. Will turn the chat on, Sue, in just a second, so that you all can interact with each other via the chat. Edge will not be monitoring the chat, though. I'll be working in the chat and I'll sort of help the most pertinent discussions sort of rise to the top for a Q&A session that will conclude Edge's presentation. If you do have a specific question on any of his materials, you won't have an opportunity to interrupt his slides or his flow. But the Q&A is the best way for you to communicate that to us. Put your question in the Q&A, and we will spend as much time as needed up until 7:30. I think Zoom will cut us off at 7:30, answering questions. So that's our evening. Uh, I'll hand it over to you, Edge, to take it from here.
Great. Well, thanks, Ron. And Ron's from Colorado Mountain School, right?
I used to work full-time at Colorado Mountain School, but now I'm full-time at Erie. I'm a program manager at Erie, but I'm
Oh,
still
right
called
on.
on by a number of providers around the Front Range, which I still have the privilege of working there.
Cool. Well, CMS and Erie are two of our favorite partners. You know, we were basically born at the same time as Erie, and we've been supporters from day one since Murph and Jean founded it. We've always been supportive of their mission of getting education out to the masses. You know, it's a really big focus of ours, is supporting our gear with education, just as important. And then CMS, of course, we're homies from Boulder. So we love to go skiing with those guys when they're not too busy teaching courses. And we've put probably 24 of our employees through their programs. So we're going to put a few more through this year. I'm trying to get myself into an AVSAR course right now. So yeah, thanks for everything you guys do. All right, so yeah, I'm one of the founders of Backcountry Access, and I'm now, you know, not day to day, but I'm the brand ambassador, still pushing education. I guess you could say I'm the education czar at BCA. And this presentation I'm doing, some of you may have seen a rendition of it over the last year or so. I did something at NSAW, something at ICAR, something at COBA, which is the recreational version of Seesaw. But I've updated it because there's a bunch of new transceivers out that I wanted to check out. And also some of my peer reviewers suggested I get a broader range of transceivers tested, especially for passive interference. So let's get started. This is what I'm going to talk about. We'll talk about the difference between active and passive interference. We'll talk about environmental interference, what a transmit pulse looks like and how it can get kind of confused by noise. False triggers and decreases in receive range and what that actually looks like in your hand when you're searching. We'll talk about some of the testing we've done in the field and a little bit in the lab. We'll talk about the 2050 rule, which hopefully you guys are all familiar with and are teaching. And then snowmobiles. That's probably the biggest take-home message, is just to be aware of what snowmobiles can do when they're turned on. And then I'll talk about a few wives' tales out there that I would like to dispel. Hopefully we'll have plenty of time for some Q&A. Okay, what's the difference between active and passive interference? Active sources of interference are things that are turned on, electronic devices that are turned on and are putting out some kind of electromagnetic field. And that field can cause false indications on your transceiver in search mode, especially if there's not a signal out there within range. If there's not a victim within range, there's a possibility that an active device on your person or in the environment could trigger your transceiver to give you a distance and direction, which is very disconcerting. And it has caused problems in the field in real situations. Another thing that can happen is if you do have a signal that you have captured, you could actually lose that signal, even though it's within range, your normal range, because that device is putting out so much noise, it's concealing the transmit signal coming from a victim. False multiple victim icons. Most of the transceivers now will tell you if you have multiple burials, and sometimes if there's noise in the area, it can be registered as a victim rather than the noise that it is. So you might see a victim icon even though there's none within range, or you might see more than one even though there's only one in range. Another thing that you can see, which is actually a benefit, is sometimes if you have a transceiver that will show you that can detect whether or not there's noise out there, it will prompt you to decrease your search strip width. So that's just another indicator that there's some active noise in the area. Passive noise is different, and there's a lot of kind of misperception about passive interference. I'd say passive interference is really just the effect of a metal object when it's really close to your transmitting transceiver. So examples of that would be a phone, an iPhone, a smartphone, whether it's turned on or off, because it's got big metal antennas in it. A shovel, because it's metal, and a foil wrapper around a chocolate bar. Active noise are things like a GPS that's turned on, a headlamp that's turned on, a phone that's turned on, a GoPro is turned on, those heated gloves. But as soon as you turn them off, they become passive. So potential sources of interference, but only if they have big chunks of metal in them. So that's very important to make that distinction. And what does a passive source of interference cause? Well, you can maybe, the distance readings on your searching beacon might go up a little because the signal can be weakened or kind of detuned a little bit. The direction arrows can jump around a little. You can lose some receive range. So this can be active devices turned on or off, or just chunks of metal. And it's unlikely this is going to affect your search unless it's kind of a harmonic convergence of factors, and they are physically nesting against each other. And it's certain transceivers and certain kinds of metallic objects. And if that metallic object is on the side of the transceiver that has the transmit antenna, so it really has to be a real harmonic convergence of factors for it to affect the search if it's a passive source of interference in transmit mode. And then another genre of electromagnetic interference, also called EMI. That's what the abbreviation is just things like overhead power lines, antennas like this. This is up at the top of Teton Pass, if you've ever been up to Shivers Ridge. And probably the worst culprit is underground power lines, because you can't see them. I can see this, and if I'm teaching an Avalanche course, I am not going to set up my beacon scenario here. You're probably going to have problems, especially with range. And but underground power lines, those are hard to see. But just one piece of advice is never set up a beacon training scenario at the bottom of a large quad detachable chairlift, because there's usually a big honking power supply going into those things. That's the voice of experience. Okay, so this is what it looks like on an oscilloscope. This is the nerdy box that our engineers use to look at signals on our instruments. There's usually a transceiver plugged in here, and this is what it looks like when you have a bunch of so-called white noise or background noise or EMI in the area and no transmit signal. This is what it looks like when you have a transmit signal and very little noise. So that white noise you just saw is down at the bottom. It's that blue wavy line, and that's what we call the noise floor. So the noise level in this case is very low, and the transmit pulse is coming in every second or so. That's called the pulse period, the time between each transmit pulse. And the signal amplitude is the strength of the pulse, or the height of the pulse. And if that noise floor inches up, let's say you have a phone in your left hand and you're searching with your right hand, and then you move the phone closer to your searching transceiver, that noise floor is going to move up and up and up. And sooner or later, when it's within, I'd say 10 centimeters or less, then it's going to get above the amplitude of that signal, and you're not going to be able to see that signal anymore on your transceiver, because your transceiver can't discern it from the noise. So that's what happens when you lose range, is that noise floor is now greater than the strength of the signal. This is what it looks like when you don't have a transmit signal out there, but then there's kind of spike noise sources, active noise sources. You know, a good example would be, a lot of times when we're out behind our shop in Boulder that we call Beacon Alley, there's a bike path back there. And nowadays it's super hazardous because there's the e-bikes flying by all the time. It really teaches you to search with your head up. But you might see one of these spikes just in between a pulse, a real pulse, just the spike of somebody going by on a bike. And even though it's not a legit transmit signal, it is somewhat near 457 kilohertz, or there's something on that bike that's got like an intermediate processing frequency or something, and it just happens to get through the filter in the transceiver that you're searching with, and it could be interpreted as a pulse. Sometimes it'll go away, if I was near that e-bike for a while, the transceiver might figure out after a while, okay, that's really not a transceiver, and after a while you might see it get filtered out. But anyways, we call this false triggers. A false trigger, that's when you get a distance display and a distance or a directional arrow, and usually it's kind of a high number, and usually the directional arrow isn't consistent and there's no cadence. So if you go out and practice a little bit just with your 5-watt radio or any kind of electronic, your GPS, just see what it looks like if you get that thing really close to your searching transceiver, to see what it looks like when you get noise. And it can be pretty obvious if you just do it a few times. So that's what's going on, is it's mistaking the transceiver pulse. You'll see in blue, that's a nice square pulse with this kind of flash in the pan that isn't actually a transceiver, but could show up as one. Okay, so this is an example of some false triggers that were prompted by a battery on a pair of heated socks. This is Lynn Wolf's left calf in my Pro 2 course a couple years ago. It was like this weather. It was like sub-zero temps. And she was just loving these socks, just bragging up a storm about them in class afterwards. And I said, hey, can I run my transceiver up your leg? And she said, sure. And sure enough, I picked up some false triggers when I got close to the battery. So yeah, you see they're kind of sporadic. They're generally pretty high.
Sporadic,
Yeah.
but that could throw you off maybe, and no, probably not in a pinpoint search.
Not if you're paying attention.
Yeah.
The signal's gonna be strong enough when you're fine searching that it'll definitely overpower this.
That guy's exactly right. Yeah, if you were doing a fine search, the signal coming from the victim, 2 or 3 meters away would be so much stronger than this that it will always show you the strongest signal when you're fine searching. So it's not going to show you this false trigger. So it's really just if there's no signal at all and you're within an inch or so of the battery of the heated socks. The heating element doesn't seem to kick out much noise at all, if any. It's the battery, and as soon as you turn off the socks, the noise goes away. All right, so yeah, in the real world, there's going to be some noise out there, and it's unpredictable, and this is maybe what you'd see at 20 meters, but if you were 40 meters away, that transceiver pulse would be half that height, and it would be lost in the noise. That's what's going on when you lose range. So here's an example of that happening right now. I have a signal 25 meters away, but I've got a smartwatch on my left hand, and it just disappeared. Even though I'm not moving, I'm still 25 meters away. And then when I pull away, I get the signal back. So that's exactly what's going on. As the noise floor got higher than the signal when that watch got within about less than 10 centimeters from the receiving unit. Now you might have noticed that it took a little while for that to happen. That's all a function of the display of the processing and display speed of the searching unit. In this case, there was a pretty good delay between when the noise source got close and when the signal disappeared. Okay, here's a heated glove, and there's actually a transmit unit right about out here, and now as you see, I have no signal even though I'm in search mode. Right here is the transmitter. So it's not until I'm within about 5 meters or so, 4.5 I think it says, that I actually picked up the signal. And that's because the battery on that heated glove is basically right next to my searching unit. And I have done lots of experiments with heated gloves, and I've seen a situation where you didn't pick up the signal until you were within 2 meters of that transmit unit. So heated gloves are, I would say, the biggest issue, but it's easily solved by just turning them off. You don't have to take them off, just turn them off. You never want to turn your gloves off during an avalanche rescue, especially if you're shoveling and if you got temps like this. So you'll see that we're now suggesting that you add a hands and wrists check to your departure check at the trailhead. Every time you go out, when you do your beast departure check, include a hands and wrist check. Make sure that anybody that you're out there knows if they have any electronic active noise sources on their hands and wrists. So heated gloves, turn them off. If they have a smartwatch, put it on their non-searching hand. If they have a GoPro, put it on their helmet, if anywhere, but not on their chest. If they have an Aura ring, put it in your non-searching hand. Those are the big culprits. I'm sure there's more. And then passive devices, I would say, are less severe. Just make sure that nobody's got their phone on top of their transmit unit in their pocket. And we'll talk about that soon here. So yeah, all these findings are based on some tests I did over the last couple of years. I got a little help from Austin at CAIC, from Janie at A3. And I found a nice quiet spot up above the CAIC headquarters in Boulder, up in the Green Mountain Cemetery. And yeah, it was an interesting place. I had to, I got permission. But I remember one day I went up there and they were digging graves where I had done my testing the day before. It was a little eerie. But basically, I tested a bunch of different things. I tested passive devices and their effect on transmit range, on the ability to pick up a signal when there was metal near the transmitter. I tested active noise sources by basically, you'll see in this picture on the right, I made this measurement banner where I measured out, 1 meter, 75 meters, 50 centimeters, 40, 30, 20, 10. I actually only measured at 1 meter, 50, 20, 10, and then touching. And then I did that with a transmit unit out at 40 meters, and then I did it with one out at 20 meters, and then I did it with one 2 meters away to see when I would lose the signal as I brought that phone closer and closer to the search unit. And then I also did it without a signal out there to see when I would start to get false triggers as I got closer and closer to the search unit with the noise source. And then what I did was I determined which were the most suspect noise sources, and I repeated these tests with a much smaller number of noise sources, and I tested the receive range I would get with a phone blocking a transmit unit, and so passive, and then I would do it with the suspect things like heated gloves, smartwatches, GoPro, and even an electronic float airbag, because there's been some talk about that too. So anyways, I only did the range testing on the really suspect items, because range testing takes a lot of work. And I was basically a one-man show on this project. So also we spent some time, me and Mike Duffy went up to Shrine Pass near Vale Pass, and we put up a sign in the parking lot that said, "Come on up to Shrine Pass and get your sled checked for noise, and we'll give you some swag." And we did that for a whole day, which was really cool, but it was hard to get people to hang out while we did that. So we got a limited sample size. So we ended up going to dealers and turning their sleds on and off and doing range checks, but it only really worked in remote locations like Alpine Motorsports in Kremling, which was really nice because it's out on the plains. There's no noise, electromagnetic noise, environmental noise there at all. I had some real problems in Denver. That's some of our favorite dealers there. So yeah, just really kind of got to see the effects of not only snowmobiles, but just environmental noise in urban environments. Made it tough, just a lot of false triggers and just threw off the results. So we had to change the strategy. But also we discovered the phenomenon of noise drag. And if you've ever done a range test, let's say you're in a course or with your friends or teaching a course, a lot of people like to do a range check every once in a while where you might have people, you might go into transmit mode and send your friends out and tell them to walk away from you and tell you where they lose the signal. And then raise their hand and they keep walking and then come back towards you in search mode and raise their hand when they pick up the signal. And you'll always find that you're going to get more range as they're walking away. They're going to get more range when they're walking away than when they're walking towards you. That's called signal drag. You can once the transceiver acquires the signal, it's apt to hold on to it. Kind of like when you're driving away from Cheyenne, Wyoming on I-80, you got an AM radio station, you might make it 300 miles before you lose it. But if you're driving towards Cheyenne, you might not pick it up until you're 200 miles away. So it's the same kind of thing, but it happens not just with a real signal, but with noise. So once noise gets into your transceiver, you can actually drag it with you a little bit. And this is something that applies particularly to snowmobiles because there's a technique that people are using where they'll do the signal search on their sled. In a gigantic scenario, you might cover some ground by using your sled to get the signal search done. But if you're searching on your sled, you're going to have problems with noise. So we'll go over that, but we did find this noise drag to be a significant issue with snowmobiles more than anything else. All right, so here's some of the results that I came up with over the last couple of years, boiled down. I mean, this is by no means comprehensive. It's just a very small sample size. There's so many different variations of each product, each noise source out there. Even one iPhone 14 might put out more noise than another iPhone 14. So the sample size is extremely limited, but I just wanted to get my hands around it. Just some general ideas. And I wanted to test this 2050 rule that people were starting to talk about. Because I was on this working group that the CAA and the Avalanche Canada put together last year, and I really wanted to do my homework so I could add some value to that group. And I'll show you their recommendations at the end here. So you'll see that I have, so I tested passive sources, and this is kind of something I did a little bit more recently. And I mainly focused on iPhones because I found in my preliminary research last year that really there's very few items that will affect the range of a transmitting transceiver. you know, there's a lot of talk about foil line jackets and shovel blades and candy bars and glue wrappers and foams. So what I found is that the foil line jackets, really, that's not really a factor. Shovel blade, not a huge deal. But foam and you know, tin foil can have some effects, but it's very reliant on where it is. The closer it is to the transmit antenna, the more effects there are, and it's very dependent on the model of transmit transceiver of transceiver that's transmitting. So here I've got a little matrix. Excuse me. I think I burned the cilia in my throat today in this weather. I think I froze it all off. So on the top row, I have various transceiver models, and if you're a beacon lover like me, then you might be able to figure out which ones they are, but I wouldn't think too hard about it. And then on the left side, on the y-axis, I guess you'd say, I have the searching transceiver. So I just tested every combination, and I chose all the latest models, 3 of which have been recalled this year. And I tested all the market leaders over the last 20 years, ones that have really kind of been the leading, most popular brands. And I just tested them with a phone on top of the transmit unit. So I would have a transmitting unit on the ground, and then I would put a turned on iPhone 14 on top of the transmit unit, and I would put it on the display side first, and then on the other side next. And then I also tested it with the harness for that unit on, which created a little bit of distance between the transmitting transceiver and the phone. And then I tried a bunch of other things, you know, I tried Faraday bags and this and that. And I also tried it with chocolate bar with the foil wrapper. Anyways, these are the results from the phone. The phone was definitely would create range losses on certain kinds of transceivers that we're transmitting. And so I've color coded it here. If the phone, and this is all worst case, which is the phone on top of the back of the transmitting transceiver. So if you put it on the display side, just that little tiny extra millimeter of space is enough to mitigate the problem. If you put it in a harness, the problem almost goes completely away. But if you put the phone or a chocolate bar with foil wrapped around it on the back of the transmitter, that's what I'm showing here. This is the worst case. And some people have gone so far as to wrap the transmitting unit in foil. They did that out of test in Canada, and the word got out that foil wrappers ruin receive range or something, or ruin transmits range. Well, I mean, nobody's going to wrap their transmit unit in foil, but the difference was the foil was on the back side of the unit where the transmit antenna is, and that can affect the range. And it's not really blocking the signal. What it's doing is decreasing the quality of the antenna. The quality of the antenna is how well it's tuned to the 457 frequency. And as soon as you start getting away from that frequency, you lose range on the receive unit. So it's not really blocking the signal, it's detuning the signal. So it's a little bit not exactly at 457.000 or you know. That's what's going on. You can see that there's certain models of transceivers that are much more sensitive to metal nearby or on top of them than others. I won't name names, but I've got them color-coded: red, yellow, and green. Red means that you could lose 50% or more of your range with metal on top of this unit. And yellow means 21 to 50% decrease potentially. And green is less than 21%. So what are the actions here? Where your transmit beacon in its harness. That's a good policy anyways, because it's less likely to get torn off. I actually last year saw one of my buddies' pockets get torn off his pants when he kind of hip checked on a steep slope in the spring, and he tore his pocket right off. If there was a transceiver in there, or if it was an avalanche and his transceiver was in there, it would have been gone. Just one example. Sarah Carpenter could give you another example. So wear it in its harness, and don't put metal on top of it in the harness, like in the pocket right above it. Even though that's probably not going to have much of an effect, it could have a little with some units, like the one in red here, the ones in red. If you're wearing your transmitting transceiver in your pocket, don't put any other metal objects in there. Don't put your chocolate bar on top of your transceiver, or your phone, or maybe your aluminum crystal card if you have one. So yeah, I mean, it's easily managed. And I mean, you really have to have a harmonic convergence of factors for it to scuttle a search. And then it doesn't matter if it's turned on or off. Like I said before, I do get a lot of questions like, okay, let's say I have heated gloves on and I'm buried, and my hand is over my face and my battery is right over my transmitter. Well, that's an active noise source, and that's not going to affect the transmit signal from your transceiver. I mean, yes, the battery has some metal in it, but I haven't found batteries to be a real true source of passive interference. So yeah, just keep that in mind. It's active noise sources apply to searching, passive noise sources apply to transmitting, because they're chunks of metal. A glove that's not turned on is not a chunk of metal. Oh, those pictures down below, you know, that's kind of a no-no, is to put your phone right up against your transceiver in your pocket. That's what we don't want to do. That's why I have a red X. And then the picture on the right is the same transceiver in a harness in a pocket, and you'll see that I've got a chocolate bar in the pocket in the jacket up above it, and that's kind of what a cross section would look like. And that actually probably would not affect this transceiver. It might possibly slightly affect one of those ones over in red. All right, so now we're going to move on to active noise sources. And these are the things that I tested. FRS radios, so that's a BC Link radio or a Rocky Talkie or a Motorola Talkabout, 2 watts. Max. Garmin InReach, the tiny little ones, awesome. Heated gloves, smartphones, POV camera, smartwatches of various kinds. I have a big Montana GPS with a big color screen on it. I have some Bluetooth earbuds I love, but I won't ski with them in the backcountry. Digital UHF, VHF radios. There's a lot of talk about these, the big 5-watt radios that are nowadays kind of trunked into the internet. They have big displays on them. I rented some of those and I borrowed a bunch from CAIC and from Jeff Sparhawk at Rocky Mountain Rescue. And then snowmobiles. This is kind of the real sleeper here. So basically, I showed you what I did is I had transmitting unit. Well, first of all, I measured false triggers with no victim within range, so to speak. At what point would I get false triggers? At 1 meter, 50 centimeters, 20 centimeters, 10, touching. And then I put a signal out there at 40 meters and did the same tests. And then at 20 meters, did the same tests. And then at 2 meters away, I would run these electronic devices up to my searching unit. So yeah, one thing that we should make perfectly clear is that in the fine search, 2-3 meters out, noise is not going to be a problem. The signal is so strong at that point, coming from the transmit unit, is going to completely outweigh any kind of noise source. Because remember how I said, usually the noise source comes in at kind of a higher distance. The false trigger is kind of a higher distance, like usually it's going to be above 20 meters or so, usually more than that. And so, if you have a victim that's 2 meters away, you're going to see that signal and you're not going to see the noise source. So I didn't bother with the fine search test after a couple of rounds of doing that. And then I found that, yeah, so basically the most kind of suspect items that I found are right here in this circle here. Is anything that's worn kind of by definition less than 50 centimeters away from your searching transceiver. That's really what you need to zero in on. Because I was getting false triggers out to, a little less than 50 centimeters at times with some of these items, or losing significant range when they were that close. So FRS radios, not an issue. If you can find one, let me know, but I couldn't find any false triggers or range loss using, a family band 2-watt radio. Garmin InReach, same thing. The display on that thing, usually it's the display and it's the electronics driving the display that create the noise in these things. It's not the signal that's getting transmitted. The signal coming out of a GPS is super high frequency. It's nowhere near the low frequency we use for transceivers. That's not the issue. And same thing with the cell phone. It's a completely different frequency. So I might be wrong, but you let me know, because I've never seen a false trigger or a range loss while making a phone call in search mode. The reason you might is because when you interact with the phone, the screen boots up and that creates noise. But things like this Montana GPS, things that have a big color screen on it, kicks out some noise. So I could get false triggers and range loss, up to 50 centimeters away. Same thing with those earbuds of mine, they have batteries in them. And then, these digital trunk radios. I would love to hear any anecdotes anybody here might have, but I wasn't able to get a whole lot of false triggers or range loss outside 20 meters with anything but this one model radio that I rented because Snowbird had complained about him, Snowbird Patrol. And yes, I was able to get false triggers and range loss, but only if the radio was mounted in the chest harness, and I could still mitigate the problems just by searching with my arm completely outstretched. But not everybody's arms are as long as mine. So Snowbird has decided to turn their radios off when they're doing a search. Which is, to me, is a little scary because, you know, in a big scenario, you might need those radios and you need to correspond with other agencies. Okay, and the snowmobiles, well, it was interesting because we found that walking in towards a running sled, you can get false triggers or range loss when you get within about a meter or less. But when you walk away, you can drag that noise and you can drag false triggers from the engine or drag the noise enough so you're not picking up a signal fast enough out to about 4 meters from the sled, from a running sled. There were a few combinations of searching transceiver and sled model where I was able to drag that noise out as far as 10 meters. Again, that's kind of a harmonic convergence of factors, but keep in mind that I think most people that have really studied this issue have found that the snowmobile company from Minnesota puts out more noise than the snowmobile company from Canada. And noise drag is a bigger issue with transceivers that do more processing and therefore have a delayed display rather than more of an instantaneous processing and display. So if you combine those two things, delayed display and noisy ignition system in a sled, we saw issues out to 10 meters away from the running sled. So turn the thing off, basically, or get away from the sled before you go into search mode. Okay, so this is the final bit of testing I did. I took the items circled that by definition are worn within or maybe plus or minus 50 centimeters from a searching unit when you're searching. So heated gloves, GoPros, smartwatches. In this case, I got myself a nice Coros Apex 2. I also played around with Apple Watch. The results were similar as long as the screen was on. That's what makes the difference, is whether the screen is on. And then I also played around with all the most of the electronic airbag models, Jet Force, the E1, All-Pride E1 system and the All-Pride E2 system, and toss that in there too, because I know there was a lot of debate over that, especially on the Canadian Association of Canadian Mountain Guides Informal X last year, which is where most controversies start. Okay, so this is what I came up with with these items, I did my range tests the same way. And when I did my range tests, by the way, I don't test ideal range with inline coupling with the transmit unit pointed directly at the receive unit, because that doesn't happen in the field. When I do range testing, I do what I think is more real world, and that's with the antenna pointed away, pointed basically perpendicular to the trajectory of the searcher. And with the searcher coming in at it at a bad angle, perpendicular, but moving the transceiver around as suggested, recommended in the owner's manuals. You want to move the thing back and forth on the horizontal plane. So that's how I did the range testing. So I would do 3 passes, at least 3 passes, and take the average max range with, let's say in this case, the heated gloves on and a transmitting unit of the brands shown at the top. So anyways, you'll see that oh yeah, so the heated gloves are definitely the most suspect active noise source, and they can really affect the performance of your search. You might pick up false triggers before you while you're out of range of the transmit unit, and then that kind of goes away, and then you start picking up the signal, and sometimes it's hard to tell the difference, but generally speaking, you're going to lose a lot of range. And in one case, I was able to get to within 2 meters of that transmitting unit before I picked it up. So these are the results. I would say that the gloves are by far the worst. A GoPro on your chest is an issue. You can mitigate the problem by just searching at arm's length, but maybe you have short arms. Just put the thing on your head if you insist on using it on your helmet. And I did worst case. I would search with the GoPro on my chest and my hands basically in an arc right around it. So that's kind of worst case. By outstretching your arms, you can almost mitigate all of it. Same thing with the airbag. The Float E2 I really wanted to test because that's what BCA offers, and that's kind of the state of the art that all the companies that are doing all pride are using, and found that with worst case, I could sometimes get a little bit of range loss if I search like right in an arc around my stomach, which isn't normally how I'd search, but as soon as I outstretched my hand, the effects completely went away. And then the watch, yeah, so the smart watches and that Coros, it was kind of variable between units, but it really matters kind of how you hold the beacon, like do you hold it up towards the display so that it's closer to your wrist where the watch is, or do you hold it at the bottom of the unit so that you add a few more centimeters? That kind of makes a big difference. So yeah, turn off heated gloves, move chest mounted cameras away from your chest, put your smartwatch on your non-searching hand, and search at arm's length when you're using, anytime you're searching, with electronic airbags or not. That's good technique because by having your hand out in front of you instead of staring down at it on your abdomen, you can see false triggers, or sorry, you can see surface clues, and you're not going to stumble over things. It's good technique in the first place. So that's what a heated glove looks like. Make sure that when you do your trailhead test, you look for that little button on your buddy's hands. And that they know what to do. All right. Okay, so this is probably what you guys have all seen. How much time do I have left, Ron?
You have 5 minutes till our scheduled stop, and then we have 30 minutes of Q&A extra time on Zoom.
Perfect. All right, so this is what our working group came out with last year, that the guys at the CAA put together. It was an awesome crew. But there's more testing going on, I've heard, by the UIAA over in Europe, lab testing, which can be very involved and expensive. So I wish them luck with that. But I know BD did some research last year, and I think their findings were pretty consistent with this and with mine. And there have been some other studies in the past, some of which were a little misleading. So this is what we came up with, and I'm on board with almost all of it. But when you are in transmit mode, try to keep all metallic objects at least 20 centimeters away from your transmitting transceiver. And why 20 centimeters? I mean, didn't I just finish saying that basically have to be nested up against each other or spooning in order for there to be effects? Yeah, but you know, things happen in avalanches and things get shoved around. Sometimes body parts get dislocated, and so do things in your pockets. So who knows what could happen? You know, your phone could be in your other pocket or something, and it could get shoved over on top of your. So, anyways, further away it is, the better. But recommended distance is at least 20 centimeters or 8 inches between your transmitter and a metallic object, like a phone. Heated jackets, foil line jackets, magnetic closures, chest mounted cameras. Well, yeah, those all have metal in them. It's unproven what effect those have on transmit mode, but it's good policy not to have those nearby. More research needs to be done there. In search mode, you need more distance, at least 50 centimeters. That's 1 arm's length for most people. We've talked about what the suspect electronic devices are. You know, this says heated gloves and electronic watches must be taken off and stored. That's under debate right now, but that's definitely the most conservative route. I keep my gloves on no matter what. But anyways, 50 centimeters, that's 1 arm's length from any kind of turned on electronic device. The various transceiver manufacturers have recommendations that you should follow. Okay, snowmobiles. Well, we talked about that one, and that's why you see this 10-meter recommendation, and that's very conservative. Because really it's you know, this is worst case with noise drag and certain kinds of sleds, certain kinds of transceivers, but 10 meters is a good policy. Better policy is just turn the sled off. Now, when you do turn the sled off, a lot of the newer sleds have really nice displays with GPS and color. That screen doesn't turn off when you turn the engine off for a while. So That's not what's creating most of the noise, but there still is noise and it's subject to the 50 centimeter rule, just like a phone or a laptop, like you've probably, yeah, next time you have your laptop out, well, you probably have it out right now. Put your searching transceiver up to it in search mode and see if you get some false triggers. Well, the same thing can happen with those big dashboard displays on an 850. So just get away from that display, even if the sled is turned off. And then this one, calling for help, this still needs more verification, but the recommendation coming from UIAA, they also came out with a set of recommendations in addition to this group I was in. Just the conservative recommendation is to get 10 meters away when making a call to the outside with a phone or a two-way radio. I haven't been able to verify that this actually affects search performance, but others claim that there is. I'd love to see it for myself. Okay, so these icons down below, 10 centimeters is one chakra width, 50 centimeters is an arm's length, and 10 meters is 2 cars put together end to end. If you don't believe in the metric system. Okay, and then one other thing, environmental noise. This is harder to mitigate. So because you can't pick up an underground power line and move it, you got to move yourself and or change your search strategy. So a good strategy is if you're not picking up a signal and you have a general, like a last seen area or something, and you're not picking up a signal, shorten up your search strip widths. Maybe do it over with 20 meter search strip widths instead of 40 meter search strip widths. That's usually going to solve the problem. All right. So yeah, one just thing I wanted to address is just some of the wives' tales out there. I'm not, how many people here are teaching Avalanche courses or have taken Avalanche courses, but a lot of times, something gets started and it gets caught or taught. And it's really kind of not really based on fact. These are a few of them. That a cell phone energy bar wrapper or electronic device will block a signal. Well, not really. We just saw that they basically have to be spooning with each other. And even then, you're just going to lose some range, not enough to scuttle a search. And it has to be a harmonic convergence of worst case factors. Should you always put your cell phone in airplane mode when you're touring? Or even not even have your phone on? Well, no. That's not realistic. I use my phone for navigation. Someday I might use my phone for an emergency. Sometimes I'm expecting an important business call, or communication from my wife. I might put it in airplane mode, but the main reason to do that is to save battery power from my navigation app, or in case I need to make a call out in an emergency. But airplane mode doesn't make a difference. What makes a difference is whether or not the screen is on and if the phone is on, because then the screen might turn on. And I'm talking about it as an active source of interference. So airplane mode doesn't make a lick of difference. There was this wives' tale that you should move 25 meters away when making a call to 911. Well, that wasn't based on science. That was based on the concept that the effective range for most transceivers is about 25 meters. So just get outside the effective range of a transceiver. You'll see that the recommendation is now 10 meters, but even that, I believe, is arbitrary. So no, you don't need to go 25 meters away to call 911. The most conservative thing to do is to turn off every single electronic device on your body. Is that practical? No. I try to operate from more from that standpoint, from more of an academic standpoint. Another one that people were teaching was that you should never put your transceiver right up next to somebody else's transceiver, or touch two transceivers together, because you will detune the antenna. Well, remember earlier I talked about what detuning is, and that's when the signal kind of gets the quality of the antenna temporarily changes, and the frequency is going out at slightly off center frequency. But that only happens when you are really close to that that piece of metal. But as soon as you move away from that piece of metal or that other transceiver, when you're doing, let's say, a trailhead check, the antenna is back in tune. It's not a permanent thing. What else? What can happen, is if you have your phone directly on top of your transmitting unit in your pocket, then yes, it will stay detuned as long as they're touching each other like that. And also, it takes more energy to send out that signal. Through various laws of physics, the power draw is greater when the antenna quality is lower. So you can go through batteries faster if that metal device is right up against your metal transceiver for a long time. Excuse me. And then never use a GoPro in the backcountry? Well, that's kind of unreasonable if you're a pro, because that's how you make your living. Put it on your head. Don't put it on your chest. There was this case a few years ago, a free ride world tour athlete got buried with something like 8 GoPros on her body, and the guide had problems finding her. Well, unlikely it had anything to do with the GoPros. They were saying, maybe it blocked the signal or something, but that's not what happens. There's not enough metal in those things to affect the signal coming from her transceiver. And the noise coming from those GoPros wouldn't affect a signal search or a course search. And the signal coming from her transmit unit would be so strong during the fine search that wouldn't be a factor. So I have seen and heard of cases where user error sometimes was noise sometimes is used as an explanation for what actually was user error by the searcher. In other words, practice with your transceiver. Learn how to use it and what weird things can happen when you're out there. Don't just go to beacon training parks, but do your searches in crazy places with multiple signals and freaked out people with running around in transmit mode, and that's real practice. Okay.
Nice. There's quite a few questions, Edge.
Good. Make
But
it day.
I'll work through them one at a time, but this is the end of our scheduled time. So if folks got to drop off, all we're going to do for the remainder is Q&A. And thank you all for coming. But do stick around for the Q&A. There's some great questions. I'm going to start working through them now. Let's see. The first one that popped in, Edge, was from Jimmy. He asks, if a transceiver is exposed to active interference or false triggers for extended periods of time, can it damage the transceiver or cause the transceiver not to function properly in the future? That's kind of your detune question.
I would say the answer is no. Yeah, but if Tony Leskala is watching, is he?
I didn't see Tony's name.
Oh, rats. Okay. He's our senior engineer. He might have some insight there, but I would say the answer is no.
Gotcha.
Excuse me.
Next from Lyle, concerning the 2050 rule, Lyle wants to know the difference between that the body mass makes transmitting. Does it matter that his body might be in the way of any sort of passive interference? If it like this, if his transceiver's on his chest but his pack's on his back, what are the consequences of that spacing?
Yeah, I mean that right there could be enough to make a difference. Yeah. So remember how I told you I was searching with my my searching hand right up against my stomach, and I had an electronic airbag on. And the supercapacitor on the airbag is right up against your back. I happen to be actually excessively thin, and I could actually pick up a false trigger occasionally just by searching right up against my stomach. So because I was, I'm gonna say I'm about 25 centimeters thick. But if you had a belly, then that would be the one case where it's good to have a beer belly. But that's not how you should be searching anyways. You should have your arm out in front of you. And that's going to solve all those issues. But yes, body mass will create distance. A transceiver signal, yeah. The water and blood and stuff, I don't think is an issue. It's just the distance that you get. And every couple centimeters sometimes makes a big difference when you're that close.
Derek asked a clarifying question about some of your testing. He wondered when you were testing phones, whether the phone was on. He's just looking for some clarification of your phone as a source of active interference and passive interference. I told him you tested both, but maybe a clarifying comment on how you tested both.
So yeah, whenever I tested for passive interference effects, and I used the phone as a piece of metal, basically resting on top of the transmitter, I always had it on. Just because you're most likely to have it on, and because I suppose that would be worst case, but it really doesn't make a difference as a source of passive interference.
Got it. Next, Brian's sort of diving into this idea of what's a bigger priority in terms of stowing a transceiver. Is it is it a higher priority to stow the transceiver screen in to protect the screen, or screen in to create a little more distance from the antenna to interference?
Um, I would definitely say screen in to protect the screen. That's how all transceiver harnesses are designed, and most of them are ergonomically shaped with a little curve to them. Well, at least they used to be. I guess I'm old school. But yeah, I mean, you shouldn't be playing with little margins like that, which way to put your beacon because you insist on putting on spooning your phone with your transceiver. I mean, it's a little bit ridiculous to think that way. Uh, just put the phone in your other pocket.
Nice.
Yeah.
Next, Jared is trying to make a purchase decision between any number of different handheld UHF, VHF radios and some of the FRS models out there.
Yeah.
And his question is about how interference might inform his purchase decision.
I would test that radio with your transceiver. I would go to one of those places that rents radios and test it. There's no substitute for that. Too bad Snowbird didn't do that. Yeah, does that answer your question?
It likely does. I coached him a little bit on the differences between the power and the frequency ranges and how the yeah.
Yeah, I mean that one unit, I'm just not sure what it was. I have asked and inquired with so many different search and rescue groups and patrols, and I've only run into one that had a problem, and it was Snowbird. And I rented that one, and I had the same problem, and it was a Kenwood such and such. I have the model number if anybody wants it. I mean, I don't want to blackball those guys or anything, but it's good information to know.
Mhm.
But other than that model, I would love to hear from anybody who's experienced major issues with their 5-watt radios.
Next from Eric. Eric's curious if transceivers can be trained or tuned to ignore noises.
Yes, they can be designed to be less sensitive to noise. There is a bit of a inverse relationship between antenna sensitivity and sensitivity to noise. You might have seen that those two units that were in red in my passive noise tests claim to have the biggest surge strip within the industry. Well, that comes with drawbacks. For every great strength, there's a great weakness. We've always focused on reliability and compatibility. Other designers are going for max range, but there's trade-offs.
Well, that might be a good segue to Derek's question. Do you think there's any technology on our horizon that supplants all these trade-offs? Is there somewhere the industry's going that might change the game?
Well, I think, yeah, there's been some efforts, but none of them are game changing. Yeah, I've played around with all the new beacons, and they're working on making noise less of an issue, but I would say they're going after the wrong issue. They're going after the passive noise problem, but I don't see that as a problem. I think some companies have done a pretty good job of minimizing false triggers. But nobody has really solved the problem of losing range. False triggers is definitely an issue, but range loss is equally as harsh. So is there a magic bullet? Hey, maybe it's AI. I don't know. I guess if I knew it, if I knew the answer, I probably wouldn't tell you because my engineers would kill me.
Oh,
Yeah.
that's a really good answer. One more question from Garrett here. Garrett's curious if a pacemaker, something that's really hard to turn on and off, something inside the body. What's that realm?
Yeah, that's a great question. My wife has a pacemaker. And I played around with it a little bit and I couldn't pick any noise up from it. I even ran my Ortovox F1 up and down her collarbone, and I couldn't hear it. That's a great tool, actually, in Ortovox F1 for sniffing out noise. Really, pretty useful. So yeah, get one of those on eBay used and use it only for that purpose and nothing else. But I did try to get my hands on some insulin pumps and some pacemakers, and I got zero cooperation from any of those big med companies. They all sent me their PDF files on their guidelines, and they'll give you that info. You should look up whatever that manufacturer is and look up their guidelines, and they probably will have Avalanche transceivers listed. And I think Medtronic, one of our engineers actually went to Medtronic, works there now. Even he couldn't get me one of those things, but he sent me the PDF. I mean, I think they say keep 25 centimeters distance between your pacemaker and any source of active electronic noise. Something like that.
Copy. Well, that's the end of our questions, Edge. I think it's probably a good time to give your voice a rest, and I'll speak for everyone. Thank you for sharing all your expertise and research and brilliant slides. You can see some of the accolades coming in on the chat. It's just it's been a real pleasure. Thank you.
Well, I'd like to give some credit to Jim Conway, Sarge. He helped me with the slides. He's a real master with PowerPoint, so I'm not going to take the credit for that. Except, you know, all those nice charts are mine and
Nice.
mine. But yeah, Sarge is the man.
Nice. Everyone, thank you. And tune in for more of our Tuesday Night Education series. We have more this month and more in February. And thanks again, Edge and BCA.
Right on. Well, thank you guys for everything you do at ARRI.
Cheers.
All right. Bye.
Signing off, everyone.